Hi, second year students. After a little break, I have switched over myself to preparation for NET. You are watching my videos. I hope without wasting time, I am starting where I have left exercise 5.2, part 3, question 6, 7, 8. How to find velocity, acceleration, distance, when we arrive at maximum height, what is the total time of the flight, etc. We have done such type of questions. So today our question number 6 reads as a particle P moves along with positive x-axis. A particle P moves along the positive x-axis. The acceleration P in time t seconds when t obviously greater than or equal to 0 is given by 3 times t plus 5 meter per second. There must be square 3 meter per second square. When t is equal to 0, the velocity of p, velocity of the particle is 2 meter per second in the positive x direction. When t is equal to t, small t is equal to capital T, the velocity of p is 6. Find the value of t. We have given an equation. The acceleration of a moving particle moving towards positive x-axis is given by 3 times t plus 5 meter per second square. That is the acceleration we have given. Acceleration is given by 3t plus 5. That's our ms square, meter per second square. It is given to us. Acceleration we have. Acceleration we have. Furthermore, when t is equal to 0, when t is equal to 0, on the outset, velocity of the particle is 2 meter per second in the positive x-axis direction. Velocity at the start, velocity is 2 meter per second when time is 0. At the outset, it's our acceleration. Difference integration of acceleration gives us velocity. Integration integrate acceleration to get velocity. Integrate acceleration to get velocity. Similarly here, 3t plus 5, it's dt. Acceleration we are familiar. It's the rate of change of displacement with respect to time. And here, simple integration 3t square over 2 plus 5t plus c. They cancel each other. The integration of acceleration is velocity. So our velocity is 3 upon 2 t square plus 5t plus c. We have given acceleration 3t plus 5 meter per second square, and our particle is moving in positive x-axis direction. Acceleration I have written. When we get integrate acceleration, we'll get velocity. When we integrate acceleration, we'll get velocity. We have gotten velocity. Now there is undetermined coefficient c. We have no idea about c, but we have given an initial condition. And when t is equal to 0, p is 2 meter per second. At the outset, at the start of journey, our velocity is 2 meter per second, where time is 0, 5 times 0 plus c. So we have the value of constant c is 2. Plug in the value of c here in order to make this velocity equation a definite one. V is equal to 3 over 2 t square plus 5t plus c means 2, we have it. Okay, moving towards next. When t is equal to t, suppose I plug in instead of small t capital T, the velocity is 6 meter per second square. Find the t at that time. Find the time when velocity is 6 meter per second. Find the time when velocity is 6 meter per second. Find the velocity when find the velocity. Find the time when the velocity is 6 meter per second. I'm saying something different. The velocity is 6 meter per second. Find the time. Find the time when v is equal to 6 meter per second. We are interested in time. So velocity is given by 6 Here it is 3 over 2 t square plus 5t plus 2. We have given velocity. Now we are interested to determine the value of t. At what time, at what instance our velocity is 6 meter per second. Our velocity is 6 meter per second. At which instance? At what time? Here. Let me write again. 6 is equal to 3 over 2 t square plus 5t plus 2. Okay. Usually I manage what is the fraction? 2 is the fraction. Just multiply throughout 2. It's our LCM or simplification in a single step. Just multiply by 2. It will become 12. 3t square. 2 5 the 10t. 2 6 the 2 5 the 10. 2 to the 4 it is. 2 to the 4. I have multiplied by 2 in order to get rid of this 2. 2 6 the 12. 3 upon 2 into 2 it's 3. 2 5 times 10. 2 times 2 4. Shift on one side, write in the standard equation, solve this quadratic. 10 times t plus 4, 12t, it will become minus 12. I have 3t square plus 10t minus 8 is equal to 0. Now, apply quadratic, it's up to you, or Milton breakup. Factors of 8, 2, 2, 2, and take this 3. What we have? 2 to the 4, 4 3 the 12. 12 minus 2, I will get 10. 12 minus 2, I will get 10. Milton breakup. 3t square plus 12t minus 2t minus 8 is equal to 0. Taking 3t common, I have t plus 4 minus 2 common. Whenever negative symbol, something is common, change all the upcoming symbols. It will be t plus 4. Both brackets are identical. We are good to go ahead. T plus 4. The other one is 3t minus 2 is equal to 0. Either or, t plus 4 is equal to 0. That is the negative value to be discarded all the time. And from this equation, and from the other part, 3t minus 2 is equal to 0. We are going to get 3t is equal to 2, or t is equal to 2 over 3 seconds. Means when our time is 2 over 3 seconds, our velocity is 6 meter per second. Our velocity is 6 meter per second. Our velocity is 6 meter per second. Initially, we have given equation of a particle in terms of its acceleration, that's 3t plus 5, and we have given initial condition at the outset that the velocity is 2 meter per second. If you integrate acceleration, you will get v. If you integrate acceleration, you will get v. I have done so, and by utilizing t is equal to 0, velocity is equal to 2, we have determined the constant 2. Then we have equation that is 3t square over 2 plus 5t plus 2. I am integrating this one. 3t square over 2 plus 5t plus c means 2 we have determined. Then we are asked at what instance, at which time, after what time our velocity is 6 meter per second. Our velocity is 6 meter per second. Then instead of velocity I have plugged in 6 and I have solved 40. As it is coordinate, I have arrived at two answers. Discarded the negative answer, and t is 2 over 3 seconds is my mine answer in that case. Going towards next question. A particle p moves along the positive x direction at the time t seconds. The velocity of the particle is given by 3t square minus 40 plus 3 meter per second square. When t is equal to 0, p is at the origin. Okay, find the distance of p and O when p is moving with when the particle is moving with a minimum velocity. We have given velocity of the particle. Velocity is given by 3t square minus 40 plus 3. We have meter per second. That's our velocity. Cool. When t is 0, the particle is at origin, means starting from O. When find the distance, we are interested in distance. Find distance Find distance when p is moving with minimum velocity. Minimum velocity. Okay, cool. Find its distance. How to get to distance from velocity? Integrate velocity to get to distance. V dt, that's our 3t square minus 4t plus 3 times dt. We have velocity can be written as distance ds over dt times dt, and here it will be 3t cube divided by 3 minus 4t square over 2 plus 3t plus c. Cancelled out, applying table of 2. Integration of velocity is distance, pure distance. S is equal to t cube minus 2t square plus 3t plus c. Now, we have given initial condition. When t is equal to 0, particle is at origin. When t is equal to 0, particle is at origin. If I put t is equal to 0, our distance is 0. So, we have the constant to be 0. The value of c is 0 in that case. 3 times 2. So, our c is 0. So, there is no need to write c. So, this is our s is equal to t cube minus t2 square plus 3t plus c means 0. That is our complete motion of the particle is given by this equation. Motion of the particle is given by this equation. T cube minus 2d square plus 3t plus 2. What we are asked, find the distance when it is moving with minimum velocity. Minimum velocity. Key lies here. Minimum velocity. Minimum velocity. How to get to the minimum velocity? That is our V. Differentiate this and try to find, apply max or minimum, extreme values concept, minimum or maximum concept. In that case, minimum. Differentiate V with respect to, that is 60 minus 4 equal to 0. We are going to get 60 is equal to 4. T is equal to 4 upon 6 means 2 upon 3. When our time is 2 upon 3, when our time is 2 upon 3, then it is moving with minimum velocity. Let me prove this. Differentiate this thing again. D square V over dt square. It will become only 6 times 1. 6 positive. 6 is greater than 0. When double derivative is greater than 0, when double derivative is greater than 0, function has min at the given value at t is equal to 2 upon 3. That's the ample proof. That's the ample proof. Double derivative is positive. Double derivative is positive. So the function has minimum at that value. Function has minimum at that value. This value is known as critical point. This point is known as critical point. Critical point means that gives us max or min. Max or min. In that case, it is giving min. If it is a point that gives neither minimum or maximum, then it is a stationary point. Stationary point or point of inflection. Or point of inflection. Point of inflection. So we have to find distance. Put value of s in that equation. We have s is equal to t cube minus 2t square plus 3t. Find the distance when particle is moving with minimum velocity. It is ample proof, double derivative is positive. It is moving with minimum velocity. That's the time where it is moving with minimum velocity. Put time in that, you are going to get the distance when it's moving slow. T means 2 over 3 cube minus 2. T means 2 over 3 square plus 3 times 2 over 3. 3 cancelled out. 3 cancelled out, and simplify the situation. It is our 2 cube means 8. 3 cube 27 minus 2 times square of 2 4 square of 3 9. Here remains only 2. 8 over 27 minus 8 over 9 plus 2. Taking LCM, 27 is LCM. 8 minus 9 3 is 27. 8 3 is 24. 2 into 27 54. 2 into 27 54. Okay, 54 minus 24. It will go 30. 38 over 27 meters is the distance when our particle is moving with minimum velocity minimum velocity at t is equal to 2 upon 3. How we get to it? Apply max and min concept, extreme value concept. How to find extreme values? For extreme values, we have to find critical values. We are interested in the max and min extreme of velocity. Differentiate velocity equal to 0. Differentiate velocity equal to 0. We are going to get our points, critical points. Critical point might be stationary points. In that case, it is a critical point because it is definitely telling us function has minimum at 2 over 3. That is the validity. Double derivative of the velocity is positive. Double derivative of the velocity is positive. So it's ample proof that it has minimum at this point. It has minimum at this point. Okay, we have reconciled both the facts. We have generated t theoretical point, as well as we have verified that it has minimum at t is equal to 2 or 3. What is the minimum distance then? Put t is equal to 2 upon 3 in the distance function. In the distance function. In the function according to which the particle moves. That is tq minus 2t square plus 3t. Put in this value, we got 38 over 27 meters. Okay, cool concept. Moving towards question number 8. That is, a particle P moves along the x-axis, third in a row with almost same statement, ditto same statement. A particle P moves along the x-axis in a straight line so that the time t seconds, the velocity of P is v meter per second, where v is this one. At t is equal to 0, P is at the origin. Find the displacement of P from origin when t is equal to 6, t is equal to 7. We have given in that case P's function. We are familiar from our base in calculus how to deal with P's function. It is first part 10t square minus 2t square when the value of t lies in the closed interval from 0 to 6. From 0 to 6. If our time lies between 0 to 6, from 0 to 6, 0 inclusive as well as 6 is inclusive, we have to utilize this, that is 10t minus 2t square. That is 10t minus 2t square. Okay, correct. And 432 divided by t square when t is greater than 6. When t is greater than 6. Okay. When t is greater than 6, that is our function to be dealt with for velocity or for finding corresponding distance or displacement. And if our particle or time lies between 0 to 6, this is the portion of the velocity to be taken to be dealt with. Now, let's come to first one. Well, find the displacement when? Find displacement. We are asked to find displacement. Displacement question mark when t is equal to 6 seconds. T is equal to 6 seconds. Okay. Hunt t is equal to 6 lies in that interval. So our velocity is given by 10t minus 2t square when t is equal to 6. When t is equal to 6. Okay. We are not interested in velocity. We are asked to find its displacement. How to get to displacement? Integrate velocity with respect to time. Integrate velocity with respect to time. It is something like integrate 10t minus 2t square dt. Integration of velocity is displacement. Let me give you a good idea. Displacement is given by, velocity is given by rate of change of displacement with respect to time. They are cancelled out, they are no more. Differentiation, integration cancel each other. We have only s, means displacement. Integrate, it will become 10t square divided by 2 minus 2t cube divided by 3. Applying table of 2, it will become 5t square minus 2 over 3 t cube. That is our distance. That's our distance for t is equal to 6. For t is equal to 6. Okay. If I utilize C here, if I write C here, I have given initial condition. When t is equal to 0, P is at origin. When t is equal to 0, P is at origin. When t is equal to 0, sorry, I am doing the latter one concept, this one. At t is equal to 0, P is at origin. At t is equal to 0, P is at origin. If I put t 0, my distance is also 0. If I put t 0, my distance is also 0. So value of c in that case is also 0. So there is no need to write c. Look, I have this. S means 0, 5, 0 square minus 2 over 3, 0 cube plus c. They are all cancelled out. So value of c is 0. I have just plugged in here. Okay. Now it is my distance 5t square minus 2 over 3 t cube. Now I am interested what is the displacement when t is equal to 6. What is the displacement when t is equal to 6? Plug in instead of t6. 5t means 6 square minus 2 over 3. It means 6 cube. Okay, 5. The square of 6 is 36. The square of 6 is 36 minus 2 over 3. 6 cube means 6 into 6 into 6. Apply table of 3 2 times. It will become. Now look at my calculation. I have gotten some lectures in number theory. Then I am not good at calculation, but I get rid of myself how to calculate without using calculator, some complicated calculation. Look at this, 5 times 36, I can write 2 times 2, 4 minus 36. Look at this, 5 times 36 minus 4 times 36. Like 5x minus 4x, I am going to get 1x means 36. 36. Or one can take common, 36 common, what remains? 5 minus 4. That is 36 times 1, that's my 36. It's my style of calculation to avoid calculation. It's my style of calculation to avoid calculation because I am not good at calculation. Okay, cool. So our displacement is 36 meter. 36 meter when t is equal to 6. When t is equal to 6. Further, we are also asked to find t is equal to what is the velocity, sorry, displacement when t is equal to 10 seconds. When t is equal to 10 seconds. When t is equal to 10 seconds. Displacement when t is equal to 10 seconds. Look at this. When t is equal to 10 lies in that interval, greater than 6. 10 is greater than 6, so our corresponding velocity function is this. So we take minus 432 divided by t square. That's our corresponding function for t is equal to 10. Okay, but we are interested in displacement, integrate velocity to get to displacement. That's we differentiate or integrate with respect to t, that is minus 432. It for integrating, write t square in denominator as t raised minus 2 times dt. It will become velocity, distance over time, derivative integration cancel each other, and here integrate negative 432 minus 2 plus 1, it will become minus 1 divided with the same power plus c. It will become s minus minus plus 432 to make t positive, right in denominator. Again, same condition is given to us. At t is equal to 0, p is at origin, means they are both starting point. So our constant is 0. So our constant is 0. So our constant is 0. So the displacement when t is equal to 10, t is equal to 10, 432 divided by 10, it will become 43.2 meters. Dividing by 10 point, full stop will become something point if we are dividing with 1 with 0. Dividing by 10, it is 43.2 meters. 43.2 meters. It's my tiny effort to you guys how to apply tiny calculus, tiny differentiation integration to get to velocity, to acceleration, to displacement, and vice versa. It's all by itself. Next.